Welcome back to part 22 of my DIY autonomous mobile robot building series. Today in part 22, using Fusion 360, we will use M3 nuts and bolts or screws to complete the assembly of the chassis, and then form a lid on the lower body to allow access to the Arduino UNO board and allow the 9-volt battery to be replaced as needed. If you're just joining us, be sure to check out parts 1 through 21. The links are in the description, and the full playlist is at the end of this video. Okay, so moving on from part 21, we have the problem of how to mount the front of each of battery pack rear hooks 1 and 3 to outer walls 1 and 2 via the uppermost holes. As shown in part 21, the robot body interferes with the M3 bolt if the bolt is inserted through the holes at the upper position. We need to remove this 33.8mm central tube, so right-click on this tube in the browser and select Remove. The M3 washer is not needed on the outer face of outer wall 1. It should instead be positioned on the inner side of battery pack rear hook 1. The same configuration applies to outer wall 2 and the upper component of battery pack rear hook 3. Scroll up to the joints and it looks as though I have found the joint for the M3 washer on outer wall 2. So let's rotate the design around to that side. Go back to the joint in the browser, right click and select Edit Joint. As you can see in the palette, component 2 is set to outer wall 2, so deselect and rotate the design around so that we can see the interface of the upper component of battery pack rear hook 3. Select the central snap point at the hole and the M3 washer glides into place. Find the joint for the upper M3 washer on outer wall 1, right click and select Edit Joint, and likewise deselect the joint from outer wall 1 and attach the M3 washer to the hole at the inner side of battery pack rear hook 1 so that the M3 washer attaches to the inner face. Select any part of the SG90 base so that we can easily locate it in the browser. Scroll down and we can find it here with a blue dashed line under it. Right click and select Isolate. Activate the SG90 base. Let's select this face where the M3 washer appears to slightly interfere and create a new sketch. Unhide battery pack rear hook 3, though it's pretty hard to see because the SG90 base is activated. Press P to project the front end and the lower front edge of the SG90 base, and project the 3mm diameter hole of the battery pack rear hook 3. Hit OK, change the line type to construction, and then select the circle tool. Sketch a 7mm construction circle corresponding to the outer diameter of the M3 washer. Select the circle tool again, change the line type to solid, and sketch a 7.5mm circle. Finish the sketch, select the extrude tool, and we'll need to hide battery pack rear hook 3 so that we can directly select the SG90 base. Select the segment defined by the 7.5mm circle and the SG90 base and extrude by 1mm. Hit OK, and there we can see the clearance cutout. Do exactly the same on the other side on the corresponding section of the SG90 base. Now right click on the SG90 base in the browser and select Unisolate. Then activate the main design. Let's focus on the front upper hole that is formed through outer wall 1. Since there is no room for a socket head of an M3 bolt, I decided to convert this hole to an M3 threaded hole so that an M3 screw can screw into it from the inside. So from Create, select Thread, and then select the inner surface of the hole, and an M3 thread is automatically created based on the 3mm diameter of this hole. Then do exactly the same on the hole in outer wall 2 on the other side. From Inspect, select Measure, select the outer face of outer wall 2, and then the face of the M3 washer that is on the inner face of the upper component of battery pack rear hook 3, and we get a distance of 20.25mm, so we'll need a bolt that is a little longer than that distance. From Insert, select Insert McMaster Car Component from the pull-down menu, select Screws and Bolts, select Socket Head Screws, select Metric, select M3 for the thread size, and I selected this alloy steel socket head screw. Let's choose 22mm for the length. Hit Download to download the 3D step file for this screw. Here the footage shows the M3 screw downloaded and positioned at the origin. So let's move the M3 screw away from the design, rotate it by 90 degrees, and also let's move it to a position that is convenient for attaching it. Rotate the design to the other side and zoom up to the M3 screw. Before we carry on, let's press A for appearance, apply black pigment onto the M3 screw and hit OK. Now select the Move Copy tool and make a copy of this M3 screw by selecting the M3 screw, selecting Create Copy on the Move Copy palette, and moving the copy away from the original. We only need one extra copy, so let's hit OK. Let's get into position and zoom up to the two M3 screws. From Assemble, select Joint, select the central snap point at the underside of the head of one of the M3 screws, and then let's zoom up to the M3 washer at the hole in the upper component of battery pack rear hook 3. Select the central snap point, and the M3 screw glides into place. Let's have a look at the other end of this screw, and we can see that the threaded end of the screw does protrude through outer wall 2, but nowhere near as much as the socket head previously did. Then attach the other M3 screw through battery pack rear hook 1 and outer wall 1, etc. in the same manner. Here the footage shows a section analysis along a vertical plane through the centers of the 22mm M3 screws. Unhide the lower body, and we can see that there is plenty of room for the ends of the M3 screws behind the body. Here we are back with the section analysis not showing and the lower body hidden again. Turn the design around to the rear and we can see that we still have a few holes through which bolts need to be mounted. Select Measure from Inspect and measure the distance from the surface of the M3 washer at the rear of outer wall 1 to the washer at the corresponding position on the inner surface of inner wall 1, and we get a distance of 24.45mm. Although not in the footage, I discovered that the socket head of the M3 bolt or screw would also interfere with the body if inserted from the outer side, so I decided to insert the M3 screw from the inner side. So we don't need this washer here, so select it, then find it in the browser, right-click and select Remove. Here the footage has jumped ahead. Zooming up to the hole here, we can see that it already has been converted to a threaded hole using the thread tool from Create. Then do the same at the hole in outer wall 2 at the other side by quickly removing the M3 washer, selecting Thread from Create and selecting the inner circumference of the hole, thereby forming an M3 thread. Now from Insert, select Insert McMaster Car Component, select Screws and Bolts, select Metric, M3, and this time a length of 25mm. We also need to select socket head screws. Let's just adjust the window for better visibility and download by selecting the serial number here, selecting the step file and hitting download. Here's the 25mm M3 screw downloaded. Move the M3 screw out of the design and to the rear. Rotate the entire design a bit. Zoom up, then press A for appearance and apply a black pigment. We'll just relabel the M3 screw to read M3 25mm socket screw. Use Joint from Assemble to attach this 25mm M3 screw from the inner side of inner wall 1, etc. at the M3 washer. Turn the design around and there we can see the end of the M3 screw poking out slightly, which looks about right. Then make a copy of the M3 screw and insert it through the corresponding hole of inner wall 2, etc. on the other side. Now from Inspect, select Measure and measure from the face of this M3 washer on outer wall 2 to the face of the M3 washer at the rear of the upper component of battery pack rear hook 3, and we get a distance of 20.75mm. So I made another copy of the 22mm M3 screw and attached it from the inner side to pass through the upper component of battery pack rear hook 3 and outer wall 2. There we can see the end of the screw at the other end at outer wall 2. However, the M3 screw doesn't seem to be extending through the hole enough for an M3 nut to be securely bolted on, so let's see how much room we have by first unhiding the lower body, then unhide the section analysis, and we can see that there is enough room for the end of the M3 screw even if it is moved to the right by the thickness of an M3 washer. Hide the section analysis and hide the lower body. So let's remove the washer at the head by right-clicking the joint, deleting the joint so that the 22mm M3 screw is released from that position. Next, remove this M3 washer by selecting and right-clicking it in the browser and selecting Remove. Then use Joint from Assemble to attach the 22mm M3 screw back into the hole, this time without the washer. Let's check the other end of the M3 screw, and we can see that the end protrudes by an amount sufficient for a nut to be screwed onto. Next, we need to measure the distance from each side of battery pack rear hooks 1 and 3 at the rearmost through hole, aligning with the holes in inner walls 1 and 2, and we get a distance of 42.2mm from washer to washer. Download an M3 screw as before, but this time choose a length of 45mm. Apply a black pigment and insert it through the hole from battery pack rear hook 1. Unhide the lower body, unhide the section analysis, and we can see that there is plenty of room at each end of the 22mm M3 screw. And then let's move the section analysis to the rear end where the 45mm M3 screw is, and we can see that there is plenty of room at each end of this screw as well. Hide the lower body again, and let's just quickly name the joints for the various M3 screws and hide each joint as well. Now it's time to attach the M3 nuts onto the ends of the M3 bolts. Select Insert McMaster Car from Insert, select Nuts, select Metric, select M3, select Hex Nuts, and download the step file. The downloaded M3 nut is initially positioned at the origin, so let's move it out of there to a more convenient position. Scroll down to the bottom of the browser and I'll just rename the M3 nut M3 Hex Nut. Press A for appearance and let's apply a black pigment. Make some copies of this M3 nut by selecting it in the browser and then selecting the Move Copy tool, check Create Copy in the palette, move the copy away from the original, and repeat that process several times to create 4 copies of the M3 nut. Then we can proceed to attach these nuts using Joint from Assemble to attach one M3 nut here, then attach another M3 nut here, here, and here. Then hide the wheel to reveal the central M3 bolt end and attach the last M3 nut there. Let's also unhide the right wheel. Here the footage has jumped ahead where I am using boundary fill to create a duplicate of the lower body. So check the cells and change the operation to New Component, and a new component is created. I renamed it Unspecified Body Part. Scroll up to the original lower body, hide it, and the copy of the lower body still remains. We'll just hide the lower body copy as well. So we'll need to form a lid in the lower body to enable access to this 9-volt battery. Here the footage has jumped to the plan view. Create a new component and label it Lid Tool. Now we need a flat surface that is parallel to the XY plane for the new sketch. So I selected the base of the HC SR04 holder and created a new sketch. We'll just rotate the design back and adjust the position. Press P for project. Project the horizontal center line. Project the inner side of battery pack rear hook 1, and we'll just hit OK for now. Select the line tool, change the line type to construction, and sketch a 25mm construction line from the origin. Change the line type back to solid. Select the line tool again and sketch a perpendicular line from the end of the 25mm construction line to a position past the projected inner surface of battery pack rear hook 1. I set the distance to 20mm. Unhide unspecified body part. Let's press P for project again. Project the shape of the rear protrusion on the lid and also the tail. Hit OK and we can hide unspecified body part again. Now right click on lid tool and isolate it, and also select the line tool. The footage has jumped ahead a little where we have a 90mm horizontal line sketched from the end of the 20mm perpendicular line. Let's use the mirror tool to mirror the 90mm horizontal line and the 20mm perpendicular line about the central axis. Hit OK and there we have an exact copy on the other side of the central axis. Select the circle tool and create a 40mm diameter circle at an arbitrary position. Select the coincidence tool tool, select the center of the 40mm diameter circle, and then select the center line of the sketch, which automatically shifts the 40mm diameter circle onto the center line at an arbitrary position. Then use the coincident tool again to make the circle coincident with the rearmost point of the projected rear protrusion. Just to make sure there are no gaps in the sketch, let's lengthen the horizontal lines to 96mm, which should be enough. Actually, we should probably remove the dimension altogether to allow it to adjust. So right-click on the dimension and select Delete. Then select the coincident tool and make the horizontal lines coincident with the 40mm diameter circle. Next, select the Fillet tool, select the horizontal line and then the perpendicular line to form a fillet, which is set at a default radius of 5mm, so let's set that to 8mm for a slightly more gentle curve. I did the same at the lower corner too, but once I did that, the sketch became unconstrained, so I added a perpendicular construction line and added 8mm horizontal and vertical dimensions for the lower fillet, which achieved a constrained sketch again. Hit select and then let's remove some of the excess projected lines by right-clicking on the lines and selecting Delete. Next, select the Trim tool and select the inner circular sections of the 40mm diameter circle to remove them. So that's the basic shape of the lid. Change the line type from construction to solid. Next, select the Offset tool and select the periphery of the lid profile we've just sketched. Let's adjust the offset to 0.5mm. Here the footage has jumped ahead with the sketch finished. Tilt the design a little, zoom right up, select the Extrude tool and select the 0.5mm space that we created using the Offset tool. Move around the various sections that define the 0.5mm wide perimeter, and once they are selected, drag down the Extrude arrow so that the extruded body penetrates through the lower body and hit OK. We'll need to activate the main design before we carry on. I think you can see that the lid tool is penetrating through the rear lower surface of the lower body as well as the upper surface, so we'll need to adjust the length of the extrude. Look for the extrude icon in the timeline, right click and select Edit Feature. We'll need to make sure this rear portion of the lid tool is inside the lower body and not sticking out. So drag the extrude arrow up a bit. That's probably enough, but let's check by taking a look inside the lower body. And there we can see that the lid tool is protruding inside the lower body by an appropriate amount. I'll just reposition the design and select the Combine tool. Now select the lower body as the target body, change the operation to Cut, and then select the Lid tool as the tool body. Hit OK and the lid tool disappears while cutting through the lower body. So there's the lid nicely cut out. Hide body 1 here and the lid disappears, revealing the opening. Let's rename body 1 to Lid. Right click on Lid tool at the bottom of the browser and unisolate it. This reveals the relationship between the chassis and the lid opening. This lid opening allows easy access to the 9-volt battery for replacement and also easy access for the Arduino UNO. Here's the rear view and the side view. Unhide the lid body. Click here for part 23. If the link isn't showing, part 23 isn't quite ready, but it should be soon. Check the description for my upload schedule. Thank you for watching.